All right, let's get after this address bus. So I have procured some real small wire here for this thing, just like the data bus. I'm going to use, I don't know if it's 28 or 30 gauge, but it's real small wire for this thing. It's going to make it a lot easier to work with. The address bus is going to be a lot more involved than the data bus because we got 20 wires instead of 8 to run. So we're going to be at this for a little bit longer. Okay, so here's my A0. Pin 31 on my part here. Decent. And then on the flash, it's going to be pin 12 right there. So I'm going to do the same thing with the address bus that I did with the data bus. I'm just going to plug 2 wires into the same pinhole on the flash device, and then I'm going to solder them both at the same time. It's going to make it a lot easier to be sure they're making contact. There we go. That looks nice. Okay, it's going there. A little bit more. So I just had this wire here just frayed a little bit before I put it in, and it's really hard to see, but it looked like it was touching the neighboring pad. And if it had been touching the neighboring pad, then of course there probably would have been a solder bridge between those two, which would cause a short. So you gotta be real careful when you're soldering these guys in, especially with this stranded wire. If you end up using stranded wire, you wanna be real careful and make sure that the strands don't fray as you're sticking them into the holes in your board. So one thing about this I probably should have mentioned is that the drive strength on the 68000's address buses and data buses is very weak. So it's not able to, every time you add an extra, excuse me, every time you add an extra pin to this thing, like let's say we were, instead of having 2 memories on this guy, right? Let's say we were to have 4 chips, right? 2 flashes and 2 RAMs, let's say. Every time you add an extra pin that one of the wires on the address bus or data bus has to drive, it creates an additional load on the internal circuitry inside the chip. And the internal circuitry inside the chip is really not designed to directly drive the pins on a lot of memory, right? That's called the fan out, the number of chips or the number of loads that a digital circuit can drive. So if you try and put a lot of memory on one of these things, you can't wire the memory directly up to the CPU, right? What you have to do is you have to add additional driver circuits in between the CPU and the memory, right? The driver circuits, they have some special ICs that have high drive strength on them. And they would sit in between the CPU, and so then the CPU would only have to drive 1 input pin on one of those driver circuits, and the driver circuit can drive a bunch of loads. You know, you can hook the driver circuit up to many loads, and it doesn't have a hard time driving a lot of, you know, has a high fan out is what the technical term is. It can drive a lot of loads. So in this case, we can get away with not using driver circuits on this board because we don't have very many memory chips here. We only have 2 memory chips, and we'll probably add a couple of peripheral devices to it. So we don't need to worry about having too much of a load on our address bus and our data bus. But if you have a lot of memory chips, or let's say if you use a 16-bit data bus, so right now we're only using an 8-bit data bus, right? But if we use a 16-bit data bus, we would need to have a low byte chip and a high byte chip, right? So the flash memory would be split into 2, right? So it would have 1 flash memory for the low byte and 1 flash memory for the high byte. And also for the SRAM, same for the SRAM. 1 SRAM for the low byte and 1 SRAM for the high byte, right? So there'd be a total of 16 bits of data bus split across 2 chips. Okay, so we have a total of 2 flashes and 2 RAMs, or maybe more. Maybe we'd have 4 flashes and 4 RAMs or whatever, right? And as soon as you do that, you have to run the address lines. Every address line has to be run not just to 1 chip, but to 2 chips. So we'd have 2 flashes and 2 RAMs. So we have to run every address line to a total of 4 chips, right? And so that significantly increases the amount of fan out that we're asking each address line to drive. And if we do that, then we definitely need to use some driver ICs to do that, right? To boost the drive strength of the address pins and the data pins. Okay, so the reason we chose only to use 2 memory devices on this thing with an 8-bit data bus is because we don't have to worry about, it reduces the amount of soldering we have to do, obviously, because we only have to run 8 data wires, right? And the address lines only have to go to 2 chips, right? But then we also don't need to have those intermediate bus driver chips in there too. So it significantly reduces the amount of soldering you have to do if you only use the 8-bit data bus. But if you were ever to do a design, we're probably going to make this design into a printed circuit board. And if you do that, then it's probably worth using a 16-bit data bus, because you don't have to solder these wires individually if you're doing it on a printed circuit board. Right? It's much easier to just, you just have to put the chips in and solder the chips. And actually, as I've done this, going through this process of building this board by hand, I have realized that it is truly insane to do this. And I kind of regret doing it. I kind of regret taking this project on. I think maybe 30 years ago, even 20 years ago, it might have made sense to do this, because printed circuit board manufacturing was not as widely available and as cheap as it is today. But these days, you can get a printed circuit board manufactured for probably under $50 that would do this. Maybe $75. No more than $75 for a printed circuit board. All right, this is going to be a long process. We have 20 address bus wires that need to be soldered, and I don't want to subject you guys to all of those. So I'm just going to finish soldering the address bus off camera, and then we will resume working on the address decoder next.